This is homework set 32, questions 9 and 10. Well, question 9 tells us that Lamont wants to fence 3 sides of a rectangular exercise for his dog. So the fourth side of the exercise yard will be a side of his house. And he's got 100 feet of fencing available, and we're supposed to find the dimensions that will enclose the maximum area. So let's start here. Let's draw the side of the house. This will be the side of the house, and then the rectangular area that he wants to enclose will be right here. Now, what we want to do is we want to maximize the area. So what I do when I do these problems, I write down what I'm going to do, what I want to do. I want to maximize the area. Now, I don't have an area function, right? There's nothing here in this problem that says what the area is. So what this tells me here is that I have to get an area function. Fn for function. Okay, now this is a rectangle. So I know that the area of a rectangle is length times width. Right, so the area, I'll do a little rectangle here. The area of a rectangle is the length times the width. So let's look at what we have here. I've got this rectangle, and I've got a width, if I call that a width, a length, and another width. I don't have anything here because this is up against the wall. So I have a width, so I have 2 widths and a length. Now how about if we did this? What if we let this width here be x, then this one over here would be x, and now what I need to do is I need to get this length. Here's how I'm going to do that. Look back up to the problem. What we have is 100 feet of fencing available. Now, I've got 100 feet to go here, here, and here. So just for example, what if this was 10 feet? If this was 10 feet, this was 10 feet, so that would be 20 feet, and then I've got 100 all together, so 100 minus 20 would leave 80 here. But let's do this in general. So I've got 100 feet all together, and I have used up x over here and x over here. So what I've got is this. I have 100 minus an x, like minus this x, and then minus another x. So altogether, this is going to be 100 minus 2x. So now I've got a length and a width. So the area of this rectangle is going to be the length, which is 100 minus 2x times the width, which is x. Okay, so you see what I've done here? This length, the length here, that's the 100 minus 2x, and the width is the x. So let's multiply it by 3. So we'll get the area of that rectangle is, or I just distribute, I'll get 100x minus 2x squared. Now I'm just going to rewrite this, saying that the area of the rectangle is negative 2x squared plus 100x. And now you can see that this is a quadratic polynomial, right? Here is ax squared plus bx plus c. So what I've got is that a is the negative 2, b, that's 100, and c, well, that's a 0 out there. Now in that quadratic, the leading coefficient's negative, so it's a parabola, quadratic, so it's a parabola. Leading coefficient's negative, so if I was to graph this or draw this, it would look like this. I'll do it up here. It would look like this. It's a parabola that opens downward, and there is a maximum value. So that maximum would occur right here, and then that's going to be at the vertex. So all I need to do now is get the components, the coordinates of that vertex. Now, here's what I know. I know that the x component is negative b over 2a. And our setup is this, negative b. What is b? b is 100. So I'm going to get negative 100 over 2 times a. A is right down here. It's negative 2. All right, so we're going to get negative 100 divided by negative 4. So how about 25? That's the x-coordinate. And we can get the y-coordinate by just taking that 25 and putting it right back in here for x. So we will get negative 2 times 25 squared plus 100 times 25. This is negative 2 times 25 squared. I just happen to know that one. 625 plus this one's going to be 2500. So negative 2 times negative 625 is negative 1250 plus 2500, which turns out to be 1250. So here's the vertex. The vertex, I'll just put it right in here. The vertex is going to be here at 25 and 1250. Now, what is this x value? That x value, remember back over here? What is that x? It's a word problem, so you have to look back to see what all these numbers are. That is the width. So I know the width. I'm trying to find, here's the question, find the dimensions that maximize the area. So I have the width. Now the length is right here. All right, so what I know so far is that the width is 25 yards, and the length, well, that's going to be the 100 minus the 2x, which is 25. So that's 100 minus 50, so that's going to be 50 yards. All right, so that's part of what we want to do here. So here's what I know. The width is 25 yards. The length is 50 yards. And then there's another part of the question. All right, here's what I've got. Another part of the question is this. Find the area. All right, well, the area, that's this value right here, right? That was the area. Length times width. All right, or you could just do it like this. 25 times 50. That is that 1250. All right, so the area is 1,250 square yards. Question 10 tells us to graph the parabola, then fill in the blanks with the vertex. Okay, so that's going to be down here. I didn't copy that here. But here's where the vertex is, right? We're in the vertex form. So the vertex here, the vertex is at, all right, now the x component is inside, and it does the opposite of what you think. This says minus 2, so it actually should be plus 2 when I go down here. If I was to graph it, it goes 2 to the right, so this is going to go 2 to the right, and then the outside part tells us the vertical. And the vertical does just what you think it does, plus 2, that's going to go up 2. All right, so we're going to have the vertex at 2, 2. Let's graph that. So I'll start at the origin. I'll go over 2, up 2, put a point there. Now, this parabola, see that? Opens downward. All right, so I'm going to run my regular parabola numbers here. I'm going to start here at the vertex. I'm going to go out 1 and then up or down 1. Now I go down because of this negative sign here. So I'm going to go out 1, square it, down 1. That'll put me here. Oh, wrong number. Here and here. Then start at the vertex, go out 2 in both directions. Square 2, you get 4. So down 4, over 2, down 4. That'll put us here. And we're over here. Okay, now we can probably do one more. What if we did this? What if we went over 3, square it, you get 9. So there's 2, 3, 4, 5, 6, 7, 8, 9. Just made it. Okay, it takes us right down to here. All right, now I'm going to draw a smooth curve through these. Oh, it looks like I missed it. It's really over here, right? Not that one at all. All right, and this one over here, I keep coming down. I think I'll get it. Okay, so there's the graph and the vertex. And that concludes our work on homework set 32.